Before we take a water sample, we want to make sure that we're in an appropriate place. So we want to take water to figure out the water quality of this creek. So we're down far enough from a road culvert and there aren't any point sources around. So we're going to take water from the middle here in this run. So we're not in a riffle and we're not in a really slow pool. Everything I do, I want to be standing downstream of where I want to sample so I'm not stirring it up and affecting the water quality of that sample. But the first thing I'm going to do is triple rinse the bucket to make sure that it's clean and make sure that the water quality that we get in the bucket is representative of what's in the stream, not of our last sample site. So I'm going to start out by triple rinsing the bucket. So I just fill it up, rinse it out, dump it out, all downstream of where I'm standing. And now I can take my sample upstream of where I've ever stepped. And now I'll use this bucket of water to fill all of my sample bottles so they all have the same water and represent the same water quality. We use several main kinds of bottles when we sample for water quality. Oftentimes when we're looking at our metals, we'll use these HDPE wide mouth bottles. These are best for samples where we're going to fill it up and then we're going to add acid to it to keep metals in solution. So this is typically what we're going to use for our metal sample. Often when we're in the field, we'll take one of these filtered and one of these unfiltered. This is a flexible cubitainer. This is often used for a sample where we need to purge the sample of air to preserve the sample. And so this is used for things like solids and alkalinity and acidity, things that would change due to oxidation. So we purge this of air. This is called a VOA. These bottles are used for samples where we need to keep gases that are in the water in solution. So they have a Teflon septum on the top, and certain analytical equipment can just pierce through it to take the sample for analysis. This one is an amber one. They also make them in clear. Amber bottles, whether they're glass like this one or plastic, are used to prevent oxidation from UV light. So it's another preservation technique. And with these bottles, they have to be filled all the way to the top and capped with no bubbles and no air. All right, so this is a cubitainer. It's a flexible cubic plastic container that we use for samples where we need to get all the air out. So to use one of these, first we're going to pull the neck out. We're going to open the lid. You never blow into it because that's going to affect the quality of your sample. And so you have to reach in and grab the plastic and open it out. This is easier said than done. Sounds like a pretty easy task, right? But especially in the winter when this plastic gets a little bit harder, it can be hard to open these out. And so sometimes if you can't get it out all the way into a cube, you'll let the weight of the water open it out. So now that I have it open, I'll hold it around the rim and have another one of my sampling team pour water into it and get it as full as possible. Fill it all the way up. Yep. Yeah. So now my next task is to get all the air out of the sample. All right, so now we have to get all of the air out of this cubitainer, so there's a little bit of air in it. So you can see here that there's a bubble up at the top, so we're going to try to get that whole bubble into one bubble. And usually that takes kind of patting it a little bit and working the bubble around. And now we want to tip that up so that it's all up in the lid. And sometimes bubbles get stuck up around the rim, and so we have to kind of pat it and tip it to try to get those all in the rim. So now my favorite way of getting all of that air out is to put my hand on the bottom and apply a little bit of pressure and open the lid just a little bit so that water can come out. And I'm gonna kind of tip it around like this so that all this water is coming out, and then tighten it as I continue to hold that pressure. And then I check to see whether I got all the bubbles out, and there are no longer any bubbles. So this is now a purged cubitainer. All right, so this is a VOA bottle, and we use it for volatile organic compounds. Because volatile organic compounds tend to evaporate really easily, we need to make sure there's no air in the bottle. We also need to fill it slowly and carefully so that we try to keep those volatile compounds in the sample as much as possible. So we open it up, we fill both the bottle and the lid all the way so that there's almost like a bubble from surface tension. So there are a few bubbles on the top here, so I just kind of tap it a little bit to get those bubbles off the top of the water. Might have to tip it a little bit or pour a little bit from the lid into it. And now to cap this, to make sure that I keep a sample that has no air in it, I'm going to quickly cap it with my cap full of water and screw the lid on, and then I'll check for bubbles. Oh, I've got one bubble, so I need to fill it up again. So I'm going to just refill it, refill the lid, and I'll use that to kind of top off my bottle, get a little bit more in my lid. And now with a full lid and a full bottle, I'm going to cap it and screw it on. And now I'm bubble free. With an unpreserved bottle, you have unlimited chances to get all the bubbles out. If there's a preservative in the bottle, typically you only have 2 tries before you have to try for a new sample bottle. We often filter our samples to see the truly dissolved fraction. We typically will filter using a 0.45 micron filter. I'm going to show you 2 different filtration setups that we use in the field. This is the one that we use most commonly. It's a syringe attached filter housing using glass or nylon 0.45 micron filters. So what we do is we'll take our syringe housing and suck up some of our sample and rinse it and squirt that out. We'll do that 3 times to triple rinse our syringe so that our syringe only has in it the sample we're trying to get. This is part of our quality assurance. All right, we can then set that aside and set up our filter housing. So we take this apart. There are O-rings in the top and the bottom, which must be in place. This O-ring is not quite seated, so now it is. And then we take one of these membrane filters. So it's just like it feels almost like a piece of paper, and it's a thin glass membrane filter. Here's a thin glass membrane filter. I'm going to put the lid back on there. So we place that on our filter housing, up, making sure that our O-rings stay in place. If they don't, sample will leak everywhere and we won't get a clean sample. So we screw that together. Typically, I use them like this because this will seat over the top of a bottle well. Technically, it doesn't matter which direction you use it, which direction the flow goes, as long as you're consistent. So then what we do is we suck up a full syringe of our sample. And we use that whole syringe of sample to rinse our filter. We're now ready to fill this again and actually fill our sample bottle. Our first thing that we would do though is use the filtered water to triple rinse our sample bottle, and then we would fill our sample bottle with filtered sample. We discard the filter after each site, so we have a new one each site, and on particularly turbid water with a lot of solids in it, you may have to change your filter out during a sample. You'll feel it gets harder and harder to push the sample through with the filter. Also in the winter, sometimes these syringes get a little bit brittle and it can be easy for the tip to break off, so it's a good idea to have a spare in your bag. Another method for filtration are these large cartridge filters. So this is a 0.45 micron cartridge filter. It has a direction of flow arrow. And in order to use that, we have this full squeezy bottle that has been triple rinsed and filled with our sample. And so what we would do is we would attach the barbed endings of this filter to the squeezy bottle and push the sample through. Again, we would rinse the filter, purge off a little bit of the sample first before rinsing our bottles with filtered sample and then filling them for the day. This can take a little bit of force. I like to push it on my leg, so use my leg for pressure to push the sample through this filter.
After we've taken our samples and filled all of our bottles, we then need to preserve them. Some are preserved just by purging air, like we showed you with the Cubitainer and the VOA bottles. Some are preserved with an acid or other chemical. Acid is the most common preservative. We use nitric acid for our general metal samples, sulfuric acid typically for nutrients. We use hydrochloric acid for components that will oxidize easily. Usually the lab will tell you what you need to preserve with and may provide that preservative as well. We also will transport our samples on ice to slow down any chemical reactions and keep those samples cold until they get to the lab.